Hello everyone, I'm Irfan Faisal, a second year student in Digital Business and Innovation major. Today my topic for Introduction to Computer Networking is Global System for Mobile Communication, in short GSM. So this presentation will be an introduction to mobile communication standards, GSM. So let's dive into it. So first let's ask, what is GSM? So GSM is a widely used digital mobile network, especially in Europe and globally. It utilizes time division multiple access TDMA to digitize and compress data, transmitting it through channels divided into time slots. So GSM operates at 900 MHz or 1800 MHz frequency bands, and it is used by over 5 billion people across more than 210 countries. So a fun fact about GSM is that GSM introduced the concept of using a SIM card for mobile devices for the very first time. Next, let's look at the history of GSM. So the key criteria for GSM was that uh, the idea behind GSM is that to support for international roaming and handheld devices. So and they also have in mind to have a high speech quality, low service cost, and ISDN capability. With keeping that in mind, there have been continuous development in a GSM. um, there are for the milestones in 1983, CEPT began GSM development to establish an efficient global digital standard. In 1987, there has been an agreement signed by 13 European countries to deploy GSM. In 1989, ETSI assumed responsibility for the GSM project. In 1991, GSM launched in Finland and expanded to 1800 MHz frequency. And the global impact of GSM is that by 2010, GSM powered 80% of the global mobile market, and it marked the retirement of 2G GSM networks, with Singapore decommissioning its network in 2017. Then next, let's look at the network components of GSM. So there are five network components of GSM. One is mobile devices, two is global roaming, three base station subsystem, four base transceiver station, and five network switching subsystem. We'll not talk about all of these over here, and we will talk about all of the components of GSM network in detail in our next slides. Okay, first let's talk about our mobile device. So mobile device is our user equipment. We all have our mobile devices. So the role of mobile devices in GSM is that it communicates with the network using a hardware component and a SIM card. Next is our global roaming. So what is global roaming? GSM networks in different countries have agreements to allow you to connect seamlessly. For example, you can either use your existing SIM card and pay roaming charges, or you can swap your SIM card with a local one in the foreign country to reduce cost while using the same device. Next comes is the base station subsystem, BSS, which is a collection of equipment that facilitates communication between your mobile device and the network's core system, and the role of this is acts as the bridge that carries your phone's signals to the network and vice versa. Next is base transceiver BTS, base transceiver station, which stands for BTS. So think of this as the radio equipment, including antennas that your mobile device connects to. So basically, these are the network tower we see. So the role of this is it sends and receives signals, like for example, calls, text, internet data to and from your phone. You might see this as cell towers. That what I just said. So next, our is base station controller, which also stands for BSC, and the role of this is controls how calls and data are routed from one BTS to another, ensures smooth communication as you move from one area to another, like switching towers during a car trip. Our next component is network switching subsystem, which also stands for NSS. So what it is? This is basically the brain of the GSM network, managing core operations. And the role for this is tracks location, connects calls, and routes messages. And the key components of NSS is there are two components of NSS. One is mobile switching center MSC, routes calls and takes and connects to other networks. Two is home location register HLR, stores user details and tracks location for call or message delivery. Our last component of GSM is Operation as Support Subsystem OSS. So what it is basically tools and systems used by the mobile network operator to monitor, manage and maintain the network. And the role of this is keeps the network running efficiently, ensures there are no major issues or downtime in the service. I know all of this may be a little confusing, so let's have an example. Let's have a real life example that will help you to visualize and understand the concept of GSM more efficiently. So, for example, imagine you are calling a friend. So, what will happen? Your mobile device will send a signal to the BTS, which is the network tower. Then the BSC handles your device's request and passes it to the MSC. The MSC will look up your friend's information in the HLR and routes the call accordingly. Throughout the OSS monitors that everything is working smoothly. So that basically happens when you call your friend or family members. So next, let's talk about the GSM versus CDMA versus LTE, the key differences between this. So we have talked about GSM. What is GSM? It's like it has been the early global standard which used TDMA for data encoding, and it introduced GPRS and Edge, and which is for 2G or 2 which corresponds to 2G or 2.5G data, and it has been widely adopted outside the US initially, not in the US first. Next come is CDMA, which stands for Code Division Multiple Access. It is has introduced with IS-95 and is a more efficient spectrum usage, which has been evolved into 3G with WCDMA for EMTS. Next come is LTE, which stands for Long-Term Evolution. So this is basically GSM based, and it has a major upgrade over 3G in data speed, and it has been transitioned to 5G. So builds on LTE with new protocols for faster, more global connectivity. And here is the advantages and disadvantages of our GSM. So the advantages of GSM is it's a universal standard, works in over 210 countries, and has affordable infrastructure, lower deployment and maintenance cost, interoperability, devices can easily switch between networks, secure communication, and encrypted data transmission. And the disadvantages of um, GSM is that it's a slower data speed. Basically, the data speed is a 2G speed. Limited bandwidth can handle fewer simultaneous calls and single signal interference, susceptible to congestion in urban areas with high traffic. And here is a comparison chart between 2G, 3G, 4G, and 5G networks. And here you can see the data speeds and technology tab and everything. Um, you can save this chart for later. So let's talk about the applications of GSM. So it's pretty obvious that the main application of GSM is in voice communication, and which is designed for high quality voice calls. And the impact is that reliable communication for millions, especially in areas without advanced networks. Next is data connectivity, supports internet browsing via GPRS or an EGE edge. Use cases like email access and lightweight application relevances enable mobile internet in regions without 3G and 4G data, because not everywhere in the world there have been access to 3G, 4G, and 5G network. The next is short message service, introduce texting with messages of up to 160 characters, and the importance is critical for notifications, banking alerts, and two-factor authentication. So we'll conclude here, and let's talk about, in conclusion, let's talk about the GSM and the impact of GSM. GSM has revolutionized communication. It has established a universal standard that has been transformed global mobile communication, and it has provided reliable voice calls and text messaging essential for billions worldwide. It has paved the way for advanced technologies like 3G, 4G, and 5G. It has enabled mobile internet revolution through GPRS and Edge, and is still vital for IoT and M2M communications, offering reliable connectivity for low-speed data application. So thank you everyone for your attention, and thank you for listening to my presentation on GSM. I hope you have now a better idea, clear idea what GSM actually really is. So thank you for listening. Have a nice day, everyone.